Hello everyone, myself Shivangi Desai, your instructor for the video series of data mining and business intelligence. Today's our topic is data warehouse schema. So let's get started. First, we will have the look at the dimensional modeling. Dimensional modeling is a data structure technique optimized for data storage in data warehouse. The purpose of dimensional modeling is to optimize the database for faster retrieval of data. A dimensional model in the data warehouse is designed to read, summarize, analyze numeric information like values, balances, counts, weights, and etc. All this content are stored in a data warehouse, where in contrast, relation models are optimized for addition, updating, and deletion of data in a real-time online transaction system. This dimensional and relational models have that unique way of data storage that has specific advantages. For instance, in the relational mode, normalization and ER models reduce redundancy in data, whereas on the other hand, dimensional model in data warehouse arranges data in such a way that it is easier to retrieve information and generate reports. Dimensional model is the underlying data model used by many of the OLAP systems. Dimensional models are built by business process area, say for example store sales, inventory, claims, etc. Because the different business process areas share some but not all dimensions, efficiency in design, operations, consistency is achieved using conformed dimensions, that is, using one copy of the shared dimension across all the subject areas. Now let's discuss the elements of dimensional data model. First element is fact. Facts are the measurement, or we can say metrics, for facts from your business process. Say for example, sales business process has a measurement would be quarterly sales number. Next is dimension. Dimension provides the context surrounding a business process event. In simple terms, they give who, what, where of a fact. In the sales business process, for the fact quarterly sales number, dimensions would be customer names, location, product name, and etc. Next is attributes. The attributes are the various characteristics of the dimension in dimensional data modeling. In the location dimension, the attributes can be state, country, zip code, and etc. Attributes are used to search, filter, or classify facts. Dimension tables contain attributes. Next is fact table. A fact table is a primary table in dimension modeling. A fact table contains measurement or facts and foreign key to dimension table. Last is dimension table. Dimension table stores fields that describe the facts. It includes descriptive data about the numerical values in the fact table. A dimension table contains dimensions of a fact. They are joined to fact table via a foreign key. Dimension tables are denormalized tables. The dimension attributes are the various columns in a dimension table. Dimensions offers descriptive characteristics of the facts with the help of their attributes. No set limit set for given for number of dimensions. The dimension can also contain one or more hierarchical relationships. Now let's discuss the benefits of dimensional modeling. Standardization of dimensions allows easy reporting across areas of the business. Dimension table stores the history of the dimensional information. It allows to introduce entirely new dimension without major disruption to the fact table. Dimensional also to store data in such a fashion that it is easier to retrieve the information from the data once the data is stored in the database. Compared to the normalized model, dimensional tables are easier to understand. Information is grouped into clear and simple business categories. The dimensional model is very understandable by the business. This model is based on business terms so that the businesses knows what each fact, dimensions or attribute means. Dimensional models are denormalized and optimized for fast data querying. Many relational database platforms recognize this model and optimize query execution plans to aid in performance. Dimensional modeling in data warehouse creates a schema which is optimized for high performance. It means fewer joins and helps with minimized data redundancy. The dimensional model also helps to boost query performance. It is more denormalized, therefore it is optimized for querying. Dimensional models can comfortably accommodate change. Dimension tables can have more columns added to them without affecting existing business intelligence applications using these tables. Now let's discuss the data warehouse schema. Schema is a logical description of the entire database. It includes the name and description of records of all record type, including all associated data items and aggregates. Much like a database, a data warehouse also requires to maintain a schema. Multidimensional schema is specially designed to model data warehouse systems. The schemas are designed to address the unique needs of very large database designed for the analytical purpose. The most commonly used schema models designed for data warehouse are star schema, Snowflake schema and Galaxy schema. So let's start with star schema. Star schema in data warehouse in which the center of the star can have one fact table and a number of associated dimension tables. It is known as a star schema as its structure resembles a star. The star schema data model is the simplest type of data warehouse schema. It is also known as star join schema and it is optimized for querying large data sets. In the given star schema example, the fact table is at the center which contains keys to every dimension tables like dealer ID, model ID, date ID, product ID, branch ID and other attributes like units sold and revenue. Now let's have a look at the Snowflake schema. Snowflake schema in data warehouse is a logical arrangement of tables in a multidimensional database such that the ER diagram resembles a snowflake shape. A snowflake schema is an extension of a star schema and it adds additional dimensions. The dimension tables are normalized which splits data into additional tables. In star schema, none of the dimensional tables are normalized, whereas in the Snowflake schema, wherever possible, the dimensional tables are normalized to reduce redundancy. In the given example, country is further normalized into an individual table. Now let's discuss Galaxy schema. A Galaxy schema contains two fact tables that share dimension tables between them. It is also called fact constellation schema. The schema is viewed as a collection of stars, hence the name is called Galaxy schema. As you can see in the given example, there are two fact tables which is revenue and product. In Galaxy schema, it shares dimensions which is called confirmed dimensions. So that's it for this lecture. Thank you.